Hello everybody, welcome into another lesson. So today we are going to continue more with graphing rational functions. So in yesterday's lesson we graphed rational functions in which the degree of the numerator was less than that of the degree of the denominator. Today's lesson we're going to talk about graphing rational functions in which the degree of the numerator equals the degree of the denominator. So here you have the general form f of x equals some coefficient of x to some arbitrary m power plus another coefficient of x to one less power than m, and it continues over your denominator of some arbitrary coefficient of x to the n power plus another coefficient of x to the n minus 1 power. It continues. If the power in the numerator equals the power in the denominator, then your horizontal asymptote is the leading coefficient of the numerator over the leading coefficient of the denominator. So when the numerator power was less than that of the denominator, we had a default horizontal asymptote of 0. But when they're equal to each other, when the powers are equal from numerator to denominator, your horizontal asymptote is your leading coefficient of the numerator over your leading coefficient of the denominator. So let's go ahead here and get into our first example. Alright, so we have here f of x equals x plus 2 divided by x plus 3. Well, you can see both numerator and denominator are to the same degree. So our horizontal asymptote in this particular case is going to be y equals the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is also 1. And 1 divided by 1 is 1. So we have a horizontal asymptote of y equals 1. So let's go ahead and draw that out real quick. I'm going to plot that. Okay, now we still have the vertical asymptote to consider, which is going to be the same as before. You just take that denominator, set it equal to 0. So for your vertical asymptote, you're going to take that denominator of x plus 3, set that equal to 0, which should give you that x equals negative 3. So your vertical asymptote is at x equals negative 3. So that's going to be right here. So I'm just drawing that real quick so we can get a good graph of this. Alright, so now we have both horizontal and vertical asymptotes plotted. Now we can begin plotting points. So we'll start at the right of x equals negative 3. Let's go when x equals negative 2. Well, I think it's plain to see if we input negative 2, you would get 0, because in the numerator you'd have 0. So when x equals negative 2, y would equal 0. Alright, that was pretty easy. What about at negative 1? So if I put in f of negative 1, I'll get negative 1 plus 2 over negative 1 plus 3, which would end up giving me 1 over 2. So I would get a y value of 1/2 when x is negative 1. Okay. Now what if I put in 0? If I put in 0, so f of 0, I'll literally get 2/3. So I would get a y value of 2/3. And as you see, I'm getting closer and closer to that horizontal asymptote of y equals 1, but I'm not quite reaching it. If I put in 1, I would get 3 over 4, which would give me even closer. I'm going to get even closer to y equals 1, but not quite reach it. And then, of course, if let's say I put in negative 2.5, I would go lower down. So I'm going to draw this curve now, and you see it reaches that it gets close to that horizontal asymptote but doesn't reach it. And then to the left, it gets close to that vertical asymptote of x equals -3 but doesn't quite reach it. So there's the right branch of the graph. Now let's go to the left of x equals -3. Let's start with x equals -4. So f of -4, that would give me -4 plus 2 divided by -4 plus 3, which would end up giving me -2 over -1, which would give me a y value of +2. So at -4, I'll get a y value of +2. And then let's do -5. We'll go to f equals f of -5. So that would give me -5 plus 2 over -5 plus 3, which would end up giving me -3 over -2, which would give me +1.5. So in -5, I'll get +1.5. And for good measure, let's do f of -6. We'll go there too. Alright, so f of -6. So that would be what? -6 plus 2 divided by -6 plus 3, which would give me -4 divided by -3, which would be +1 1/3. Which would be about right there. So as you see, I'm getting closer and closer to that horizontal asymptote of y equals 1, but I'm not quite reaching it. I'm staying just above it. And if I go in between -3 and -4, I'll go higher and higher. So let's go ahead and draw this curve here. So the curve's going to look a lot like that. So now here's the complete graph of f of x equals x plus 2 divided by x plus 3. Alright, and I got another linear example, and then we'll go on to some other types. Alright, so what about f of x equals 9x plus 1 all over 3x minus 2? Okay, so we have f of x equals 9x plus 1 divided by 3x minus 2. So let's go for the horizontal asymptote first. I think that'll help us. So that, of course, is going to be y equals your leading coefficient of the numerator, which is 9, divided by your leading coefficient of the denominator, which is 3. 9 divided by 3 is 3. So you have a horizontal asymptote at y equals 3. That's going to shift everything upward to y equals 3. And that holds because the degree of the numerator equals the degree of the denominator. Now, what about for the vertical asymptote? Again, take your denominator, set that equal to 0 for your vertical asymptote. So we would take that 3x minus 2, set that equal to 0. Well, you would get 3x equals 2, which would end up giving you a vertical asymptote of x equals 2/3. So your vertical asymptote would actually be at x equals 2/3. So that's going to be about right there. Not going to be the prettiest drawing. I'm going to try to draw as straight as I can. But alright, there. Now I've plotted both horizontal and vertical asymptotes, so now we can begin to really draw the shape of this thing. Well, let's start to the right of 2/3. Let's pick x equals 1. So if I pick f of 1, I should end up getting 9 plus 1 divided by 3 minus 2, which would give me 10 divided by 1, which would just give me 10. So when x is 1, we're all the way up to 10. All right, let's pick f of 2. So what is f of 2 when x is 2? That would give me 18 plus 1 divided by 6 minus 2, which would be 19 divided by 4, which would give me 4 and 3/4. I would be at 4 3/4 for 2, which would be about right there. All right, let's do f of 3. So when x is 3. Well, it would help if I put the right numbers in here, would it not? Okay, so f of 3, you would get 27 plus 1 all over 9 minus 2, which would give me 28 divided by 7, which is exactly 4. So when x is 3, we get 4. And we'll do f of 4 for good measure. So when x is 4, that's f of 4. So that would give me 36 plus 1 divided by 12 minus 2, which would give me 37 over 10, which would give me 3 7/10 for my y value. So that would be about right there. And as you see, I keep going right, I'm getting infinitely closer and closer to y equals 3, but I'm staying above it, I can't quite reach it. And the further left I go, I'm getting closer and closer to that vertical asymptote of x equals 2/3, but I can't quite reach it. So let's draw this curve here. And that's about what you have to work with for the right branch. Now let's go to the left of x equals 2/3. And what better number to start with than 0? If I pick 0 for x, I would literally get negative 1/2, which would put me right here. All right, now what if I pick negative 1? So f of negative 1, that's going to give me negative 9 plus 1 divided by negative 3 minus 2, which would end up giving me negative 8 over negative 5, which would actually give me positive 1 3/5. So I'd be up to positive 1 3/5 right about there. Now let's do f of negative 2 when x is negative 2. So that would end up giving me negative 18 plus 1 all over negative 6 minus 2, which would give me negative 17 divided by negative 8, which would be positive 2 1/8. So I go up to positive 2 1/8. All right, then let's do f of negative 3. So when x equals negative 3, that would give me, let's see, negative 27 plus 1 divided by negative 9 minus 2, which would give me negative 26 divided by negative 11, which would end up giving me 2 5/11, which would put me about right there. And as you see, the further left I go, I'm getting closer and closer to that value of y equals 3, but I'm staying below it. I can't reach it. So let's go ahead and draw this curve. And then let's continue to the right branch here. And that's about what you have to look for, is this shape right here. for the graph of f of x equals 9x plus 1 divided by 3x minus 2. Alright, so these were nice and linear in each of the numerator and denominators. Now let's spice it up a little bit here. What if we have, let's flip to the next section for that. Good one. So we have f of x equals x squared minus 7 divided by x squared plus 2. Alright, so we have f of x equals x squared minus 7 divided by x squared plus 2. Well, both degrees of numerator and denominator are equal to each other. They're both quadratic. So that means you're going to have a horizontal asymptote where the y value is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. The leading coefficient of both is 1, so your horizontal asymptote is y equals 1. So we can go ahead and draw that. Let me just draw this carefully here so it's as even as can be. Okay. Now what about for a vertical asymptote? Yes, you would set that x squared plus 2 equal to 0, but what do we notice? You're not going to get any real solutions, right? Which means we actually don't have a vertical asymptote. We have no vertical asymptotes in this case. So x is defined for all real numbers since we don't have any vertical asymptotes. So let's go ahead and start plotting some points. If I input 0, let's start at 0. So 0 would be, you get negative 7 divided by 2, which is negative 3.5, right? You would start all the way there. Now, if I put in x being plus or minus 1, what's true if I square a negative number? It becomes positive, right? So let's take care of both plus and minus 1 at the same time for those x values. I literally get 1 minus 7 divided by 1 plus 2, which would give me negative 6 divided by 3, which would give me a y value of negative 2 on both counts. So at plus 1, I'll get a y value of negative 2, and at negative 1, I'll get the same, a y value of negative 2. See what I did there? I can kill two birds with one stone if I do that. Now, if I do x both plus and minus 2, again, if I square that negative 2, it'll turn into a positive number. So if I do that, I'll end up getting 4 minus 7 divided by 4 plus 2, which would end up giving me negative 3 over 6, which would give me a y value of negative 1/2 on both. So when x is 2, positive 2, I'll get a y value of negative 1/2. And then when x is negative 2, I'll get the same, a y value of negative 1/2. All right, let's do both plus and minus 3. All right, so if x is either plus or minus 3, that would give you 9 minus 7 divided by 9 plus 2, which would literally give you positive 2/11. So now you're above the x-axis with a value of about 2/11 right there, and same when x is negative 3. And for good measure, why don't we do 4? So let's do f of plus and minus 4. On both counts, you would get 16 minus 7 divided by 16 plus 2, which would end up giving you 9 over 18, which we know is 1/2. So when x is positive 4, you get positive 1/2. When x is negative 4, you also get positive 1/2. And I think we have enough to draw this curve. So here's what that's going to look like. If you go either right or left from x equals 0, you're going to get closer and closer to that y value of 1, but you're not quite going to reach it. You get this valley here, this nice bell-shaped curve down below for the graph of f of x equals x squared minus 7 over x squared plus 2. So you can get some really neat graphs with these rational functions. All right. Don't want to do that one yet. I got two more. So f of x equals negative 4x squared divided by x squared minus 16. So we have f of x equals negative 4x squared divided by x squared minus 16. Well, the degree of both numerator and denominator is the same, so your horizontal asymptote would follow suit that it's going to be y equal to the leading coefficient of the numerator, which is negative 4, divided by the leading coefficient of the denominator, which is 1. Well, negative 4 divided by 1 is negative 4. So your horizontal asymptote is all the way down to y equals negative 4, which will put you right there. Sorry about the nails on the chalkboard sound, everybody. All right. And then, of course, we got to figure out our vertical asymptotes. Well, you take that denominator of x squared minus 16, set that equal to 0, right? So take that x squared minus 16, set that equal to 0. This would factor into x plus 4 times the quantity of x minus 4 equals 0. You actually have two vertical asymptotes, each at x equals both plus and minus 4. So at both positive and negative 4, when x equals either of those, you have vertical asymptotes. So let's draw those. All right. So let me draw the two vertical asymptotes here. 2, 3, 4. That would put me right here for the other side. So there, you have two vertical asymptotes and a horizontal asymptote drawn, which are going to mean, it's going to mean the graph is split into three pieces. So we should get a very interesting curve. So let's go to the right of x equals 4. Let's start with 5. So let's do f of 5. F of 5 is going to equal what? That'd be negative 4 times 25. All that divided by 25 minus 16, which would literally give you negative 100 over 9, which would be negative 11 and 1/9. So at 5, you're way off the chart there. We might want to go with 6. What about f of 6? So f of 6, you're going to have negative 4 times 36 divided by 36 minus 16, which would end up giving you negative 144 divided by 20, which would end up giving you negative 7 1/5. Negative 7 1/5 for x equals 6. 5, 6, 7. Right there. And then let's go with f of 7. Let's do f of 7. Which would end up giving you negative 4 times 49 all over 49 minus 16, which would end up giving you negative 196 divided by 33. Which, let's see what the heck that is. It's escaping my mind for a second about what that would be. About negative 5.94, approximately. That's approximately negative 5.94, so a little bit north of negative 6. All right. Then, why don't we do f of 8? All right, so f of 8, that's going to give me negative 4 times 64 divided by 64 minus 16, which would give me negative 256 divided by 48, which let's see about what I get. So negative 256 divided by 48 gives me about negative 5 1/3. So I would get negative 5 1/3, which is going to put me a little further north. And as you see, I'm getting closer and closer to that y equals negative 4, but I'm not quite able to reach it. I'm staying below it. So for the rightmost curve, there's about what that's going to be. Eventually it gets close to each of the asymptotes. It's just harder to see because it's so far spread out. Because when x is 5, of course, it's way off the chart down there, below the chart. Now, let's go in between negative 4 and 4. We can start with values for f equals 3. Why don't we pick f equals 3? So that would give us negative 4 times 9 over 9 minus 16, which would give you negative 36 divided by negative 7, which would actually be positive 5 1/7. So at 3, you'll get 3, 4, 5, about 5 1/7 there. All right, let's go with, and you could actually say the same for negative 3. You would get the exact same thing, right? If you squared the negative 3, you're going to get the exact same thing if you made x negative 3. And then, why don't we do plus and minus 2? We'll fill in some gaps here. All right, so when x is both plus and minus 2, you would end up getting negative 4 times 4 over 4 minus 16. Well, that's going to give you negative 16 over negative 12, which would be positive 1 1/3. You would get positive 1 1/3 when x is either positive or negative 2. And then let's do when we have 1, either plus or minus 1. So when x is either plus or minus 1, you would have negative 4 times 1, or simply negative 4 over 1 minus 16, which would end up giving you negative 4 over negative 15, or simply positive 4/15. A very small positive number. And then when x is 0, well, you're just going to get 0. So the middle piece, your graph's going to look about like that. It's going to get infinitely closer and closer to your asymptotes and look kind of like a parabola for the middle piece. It'll look like a normal parabola in the middle. Now, let's go to the left of -4. So let's pick f of -5. Well, that would equal then -4 times 25 over 25 minus 16, which would end up giving you -100 divided by 9, which would end up being -11 and 1/9. Again, this is way off the chart when x equals -5, but what about -6? Okay, so let's do f of -6. Well, that would end up giving you -4 times 36 divided by 36 minus 16, which would give you -144 over 20, which would end up being -7 and 1/5. So when x is -6, you get about -7 and 1/5, which would be about right there. Okay, now let's do f of -7. So f of -7, you're going to have -4 times 49 divided by 49 minus 16, which is going to equal, let's see, -196 divided by 33, which we said was about -5.93, so that's going to put you a little north of -6. And then, for good measure, let's do f of -8. Alright, so f of -8, that would give you -4 times 64 all over 64 minus 16, which would end up giving you -256 divided by 48, which is about -5 1/3. So you'll be right about there. And as you see, the further left you go, you're getting closer and closer to that horizontal asymptote of y equals -4, but you're staying south of it. You can't quite reach it. So we'll draw that curve, and it's going to do this kind of motion and eventually get close to x equals -4. But this is what f of x equals -4x squared divided by x squared minus 16 would look like. So I think it's pretty cool how we can get all this. And I got one more. We're going to change it yet again. Alright. Well, that's definitely not going to be accurate in a minute, so I better erase all this. I think I had a cubic one for you guys. Yes, I do. Alright. F of x equals 3x to the third plus 1 divided by 4x to the third minus 32. So f of x equals 3x to the third plus 1 divided by 4x to the third minus 32. Okay. Well, the degree of the numerator is equal to the degree of the denominator, so that means your horizontal asymptote is going to equal, that means it's going to be y equals the leading coefficient of the numerator, which is 3, divided by the leading coefficient of the denominator, which is 4. So your horizontal asymptote is literally y equals 3/4. So why don't we go ahead and plot that here. It's going to be a little funky. Could have drew that a little bit straighter. As you see, I'm so glad I don't do hand-drawn graphs really anymore, because this would be hot garbage. It'd be a hot mess if I did. That's the best I can get for 3/4 that horizontal asymptote. Okay. Now, we need to get a vertical asymptote. Well, to get your vertical asymptote, right, you got to take your denominator, set it equal to 0. So take that 4x to the third minus 32, set that equal to 0. So this would factor into 4 times x third minus 8 equals 0. Well, we don't need that 4. You can divide both sides by 4. That would just give you x to the third minus 8 equals 0. So this would factor further into the quantity of x minus 2 times x squared plus 2x plus 4 equals 0. Well, for sure, x equals 2 will be your vertical asymptote, but what about the quadratic factor? You'd have to use the quadratic formula, and in doing so, you'll discover you get 2 imaginary solutions, which really don't help us any for graphing. So we have only one vertical asymptote at x equals 2. So let's go ahead and plot that here. I'm plotting it as we speak right here. Alright, so now both horizontal and vertical asymptote have been drawn. Let's go ahead and start plugging in some values. Let's go to the right of x equals 2. Why don't we do 3? So let's do f of 3. What's that going to give you? Alright, so you would get 3 times 27 plus 1 divided by 4 times 27 minus 32, which would equal 81 plus 1 divided by 108 minus 32, which would give you 82 divided by, that would be 76, which would literally end up giving you 1 and 6 76, which would be 1 and 3/38. So it's going to be very small. You would get 1 and 3/38 when x equals 3. So very small there. And then let's do f of 4. Alright, so f of 4, that would literally give you 3 times 64 plus 1 divided by 4 times 64 minus 32. Alright, so what is 64 times 3? Let's figure out what the heck that is. 3 times 64 is 192. Add 1 to that, you get 193. Alright. Now, 4 times 64, that's actually pretty easy. That'd be 256 minus 232. So that would give you 256 minus 32, which would be 224. You would get 193 divided by 224, which would be south of 1. So you notice I'm getting infinitely closer and closer to that y value of 3/4, but I'm not quite going to reach it. So your graph is going to do yet one of these measures again. Now let's go to the left of x equals 2. Let's start picking values to the left of it here. Whoops, I did not mean to erase that vertical asymptote. Hold on a minute here. Why don't we pick x equals 1? Let's pick f of 1. F of 1, well, that would literally give you 3 plus 1 over 4 minus 32, which would give you 4 over negative 28, which would be negative 1/7. So when f is 1, when x is 1, you'll get negative 1/7, which would be really further south. Now what about 0? You would literally get negative 1/32, which is even closer to 0. Now what if we pick negative 1? What if we pick f of negative 1? So that would give you 3 times negative 1 plus 1 all over 4 times negative 1 plus 32. I'm sorry, minus 32. Boy, if I could do it right. Well, that would be equal to negative 3 plus 1 all over negative 4 minus 32, which would end up giving me negative 2 over negative 36, or actually positive 1/18. So I finally have a positive y value when f is negative 1. It's positive 1/18. Really small positive value. And let's go for f of negative 2. Why don't we do that? For good measure, we'll do it one more time. So f of negative 2, that would give you 3 times negative 8 plus 1, all that divided by 4 times negative 8 minus 32. Well, that would give you negative 24 plus 1 divided by negative 32 minus 32. Well, that'd be negative 23 over negative 64. So that would actually be then positive 23 over 64 for your y value. So it's more than what we had before. And as you see, the further left I go, the more I'm increasing my y values, getting infinitely closer and closer to y equals 3/4, but not quite making it there. I hate this sometimes. Because then you have this. And so your graph's going to do one of these numbers again. So that's roughly what your graph is going to look like for f of x equals 3x cubed plus 1 divided by 4x cubed minus 32. So this is it for graphing rational functions in which the degree of the numerator equals the degree of the denominator. Next lesson will be our final lesson on graphing rational functions, which will be about when the degree of the numerator is greater than the degree of the denominator. You'll see what happens then. So I hope everyone has a great night. Take care.